Today we will start a new topic, that is electrical capacitor or electrical condenser. Now for this, first we will take some definitions which are necessary to understand the topic. Now first definition is conductor. Now what do you mean by the conductor? Conductor are those substances in which electrical current can pass easily. Generally, metals like silver, copper, aluminum, iron are good conductor. Similarly, our body is also a good conductor. Earth is also a good conductor. So, the conductors are good carrier of electrical charges. The second is insulator or dielectric. Now, in the insulator and dielectric, they are bad conductor of electricity. Means the flow of charges is negligible in the case of insulator and the dielectric. Now, why there is a conduction of electricity? The conduction of electricity is due to the free electrons which are present. If the number of free electrons are more, then that is a good conductor. If number of free electrons are less or negligible, then that is the insulator. Now, the example for insulator is wood you can take, glass you can take, mica you can take, paper you can take. So these are all insulators material. Now what is the free electrons? As I told, the free electrons are responsible for the flow of electrical current. Now what are the free electrons? In the atomic structure, we have a nucleus of the atom and surrounded by electrons. And these electrons are circulating or rotating around the nucleus in different orbits. The electron which is in the last orbit is known as the valence electron. The valence electron has less affinity with the nucleus. So, in conductor, free electrons are available. So, in the material, the free electrons are randomly moving in the material, but they cannot leave the metal. So, these electrons are known as the free electrons. And free electrons are responsible for the flow of current in the material. Now, what is the bound electron? Now, the electrons which are highly bounded in the atom are known as bound electrons. These electrons are in the orbits which are not in the valence shell. So, the electrons which are not in valence shell, these electrons are bound electrons. The bound electrons cannot move or leave. Bound electrons are always associated with the atom. Now, if we put the conductor in the electrical field, suppose this is the conductor and we have an electrical field in this direction, and we put this conductor in the electric field. What is the effect of electric field? The electrical field, this direction, so this direction is positive and this direction is negative. So, the electrons, free electrons of the conductors, they are attracted towards this side, means they will move towards the side. So here there will be excess of electron, here there will be a deficiency of electron, and due to deficiency of electron, this will be positively and this will be negative charge surfaces. So the direction of electrical field is always from positive to negative. So inside the material, the electrical field will be from plus to minus, means this E will be equal to in this direction. So E, as we put the conductor in the medium, En will be increasing, and ultimately when En is equal to E, then this transfer of electrons is stopped and this end will be negatively charged and this end will be so what will be the net electrical field? Net electrical field will be equal to E inside plus E outside. Both are the vector, and since both are equal and opposite, So sum is equal to 0. It means electrical field in the conductor is always 0. Now next definition is polar molecules. Now what do we mean by polar molecules? Polar molecules are those molecules in which the center of negative charge and center of positive side does not coincide. So in atom there are molecules, there are atoms, and in atoms there are electrons and there is a nucleus. Nucleus is the positive charge and electron is the negative charge. If the center of positive charge does not coincide with the center of negative charge, then such molecules will be known as polar molecules. So we take the example of polar molecule, HCl molecule. This is the HCl molecule. H is here, Cl is here. Cl is more and it is negative here, positive here. So direction of dipole moment will be from minus to plus. So the dipole moment of this will be in this direction and dipole moment will not be zero. The dipole moment is permanent. Whether we are applying some electrical field or not, it will be polar. So the polar molecules will have a permanent dipole moment. Similarly, we can take example of water molecule. Water molecule H and O. Now O is negative, the center of negative is towards O and positive here. So direction of electrical field due to this H and O in this direction, this H and O in this direction. The resultant dipole moment will be vector sum of this. So P will be equal to P1 plus P2 and this will be not equal to 0. Means the molecule of water molecule and molecule of HCl molecule will have a dipole moment and will have a dipole moment, and that dipole moment is a permanent dipole moment. Now next definition is non-polar molecules. Non-polar molecules are those molecules in which dipole moment is 0. Suppose we take the case of the hydrogen molecule H and H. Then this is a plus and minus coincide here, plus and minus. So direction of P1 is here, P2. The sum of vector is equal to 0. So there is a resultant dipole moment is 0. Similarly, we take the carbon dioxide, carbon, oxygen, oxygen. So negative is here, positive is here, negative. So direction of dipole moment in this direction. So the dipole moments are equal and opposite in direction. So resultant is equal. So for the non-polar molecule, the dipole moment is 0. So we can represent non-polar molecule as a sphere and its center. Means at center there is a center of positive charge as well as the negative charge. So we give it symbol as a circle. Now in the case of polar molecules, since positive and negative they are separated by distance, so we put it like this. So dipole moment of this molecule will be in this direction. So the center of negative charge and center of positive charge do not coincide in the case of polar molecules, and they will have a definite polar molecule, they will have a definite dipole moment. So this is the difference between the polar and non-polar molecules. Now if we put the polar molecule and non-polar molecule in the external electrical field, then due to the external electrical field, the center of positive charge and center of negative charge, they are stressed. Means there is some difference or there is some distance created between the center of positive charge and negative charge. So it is suppose it is a non-polar molecule. So here E was equal to 0. When there was no electrical field, E was equal to 0, P was equal to 0, as in case of the H2 molecule. Now if we apply the electrical field, then the positive, this is the direction of electric field, then negative center of the negative is shifted to this side, positive shifted. So there will be a distance between these two. So small d, the distance between the center of positive and center of negative is not 0. So d is not 0. So there will be a some dipole moment. Now, so we can also say for the, this is only polymolecule, and for the substance, suppose this is the substance which is non-polar, then there are many atoms we have considered, and the center is at 0, and if there is no electrical field, P will be equal to 0. So there will be no dipole moment when external field is not applied. Now if we apply the external field, then the molecule will be like this. So the negative will be this side, positive this side. So there will be that. So this molecule is stacked like this molecule is stacked like this molecule. So there is a stack and there is a distance between center of negative and center of positive charge. So here, when electrical field is not 0, P will not be equal to 0. So for the non-polar molecule or non-polar dielectric, the dipole moment is 0 when there is no electrical field, and when we apply the electrical field, then the dipole moment is not 0, and such type of dipole moment is induced dipole moment. This dipole moment is not permanent dipole moment. If we withdraw the electrical field, then situation will be this. Means it will again have P is equal to 0. So the dipole moment in the case of non-polar molecule in the electrical field will have a induced dipole moment. The direction of induced dipole moment will be in this direction, electrical. So they are in opposite direction. Now for the polar dielectric. So as we have considered for polar, we have considered the HCl and water molecule. Now if we take a polar dielectric, then in polar dielectric there will be dipoles, and the dipoles are in random. They are not in a particular direction, they are in the random direction. So even though they have each molecule have a permanent dipole moment, but the resultant dipole moment due to the random orientation of this dipole is equal to 0. In the case of when there is no electrical field, the total dipole moment is 0. In the case of polar molecule as well as for the non-polar. Now if we apply the external electrical field on the polar molecules or polar dielectric, then the dipoles are oriented or they are aligned in the direction of electrical. This is the direction of electrical field. This is the direction of external electrical field. So the dipoles are negative this side, positive. So they are aligned in the same direction. So they will have an electrical field, and direction of electrical field due to polarization that will be in the opposite direction. So here dipole moment will not be equal to 0 when there is no electrical field. Dipole moment was 0, but in the presence of external electric field, dipole moment will not be equal to 0. In the case of polar molecule as well as for the non-polar. So now we explain further in this way. Suppose this is the positive plate, this is the negative plate, and here there is a dielectric. Then due to this electrical, dipoles are arranged or aligned in the direction, this direction. Negative in direction, positive, negative, positive, negative, positive. Now if we consider only this area, where only one negative is left and other, then what will be the total charge? Total mark, this will be cancelled with this will be cancelled with this. So all positive and negative charges are equal and opposite cancel. So in this area, the net charge will be equal to 0. So in dielectric, the charge will be on the left surface and right surface only, whereas in the interior the electrical field is zero, dipole moment is zero, there is no charge. So there will be charge here, negative charge towards the positive plate and positive charge towards the negative plate. So here we have a positive plate and negative plate. Now this is the dielectric. There negative charge is here, positive charge. Here negative charge density is minus sigma p bata sigma p, and here it is a plus sigma p. The charge accumulated here will be equal to minus q p, minus q p. Here will be plus q p. That will be charge due to the polarization. Now direction of electrical field outside will be from left to right in this direction, whereas for the dipole in the dielectrical, the positive charge is here, negative charge here. So the electrical field due to polarization will be equal to EP, will be in direction opposite to the external electrical field. So net electrical field is the dielectrical. I write ED means net electrical field in the dielectric will be equal to E0 minus EP. The value of EP is much smaller than E0. So its direction of ED will be same as direction of E. So now we have already defined what is dielectric constant or relative permeability. Relative permeability is ratio of electrical field when air is medium divided by electrical field when another medium is dielectric. So epsilon R will be equal to E0 bata epsilon T. E0 is the electrical field when air is the medium between these two plates, and ED is when dielectrical plates here. So E0, what will be value of E0? E0 will be equal to sigma bata epsilon 0. Sigma is the charge density plus charge density on this plate and minus charge density 0. So it is equal to plus sigma bata epsilon 0 minus sigma bata epsilon 0. So the electrical field E0 will be equal to sigma bata epsilon 0. Whereas due to polarization, here the charge density is minus sigma p, here charge density is plus sigma p. So here EP, electrical field due to the polarization, will be equal to sigma p divided by epsilon 0. So we can write the total electrical field ED will be equal to E minus ED. So E is equal to sigma bata epsilon 0 minus sigma p bata epsilon 0. This is equal to sigma minus sigma p bata epsilon 0. So this is the net electrical field in the dielectric. So we can write ED will be equal to ED is equal to, here we have defined it, ED will be equal to E0 bata epsilon R. So we can write E0 is sigma bata epsilon 0. So this will be equal to sigma bata epsilon 0 into epsilon R, and this will be equal to, if we substitute the value here, substitute sigma bata epsilon 0 minus sigma p bata epsilon 0, that is equal to sigma minus sigma p bata epsilon 0. So here epsilon 0 will be cancelled and we can find the value of sigma p. Sigma p will be equal to sigma bracket by 1 minus 1 bata epsilon R. So this will be relation between the charge density due to polarization and charge density of the plate, and ER is the dielectric constant or relative permittivity of the dielectric. Now what is the polarization density? What do you mean by the polarization density? Polarization density means the dipole moment per unit volume. Now what will be the dipole moment? Dipole moment will be equal to charge multiplied by the distance. Now the charge here, due to the polarization, is Q here and minus Q here, plus Q here. So the charge is, will be equal to, dipole moment will be equal to charge multiplied by the distance between these two plates is small d. So the dipole moment will be equal to charge Q multiplied by distance. Now, what is the polarization density? Is dipole moment per unit volume. What will be volume? Volume will be equal to, if A is the area adjacent of this plate and this plate, then volume will be equal to A into D. So, this P will be equal to, polarization density will be equal to QP into D bata A into D. D will cancel, so it will be equal to QP divided by A. QP divided by will be equal to the charge density of polarization, sigma P. So this will be equal to sigma P. So this one relation we have found. So P is equal to here we take from this relation sigma P is equal to this much. So we can write P is equal to sigma P, which is equal to sigma into 1 minus 1 bata epsilon 0. So this will be the relation for the polarizing density. Now we know that when it is an electrical field, then we apply the electric field. If we increase the electrical field, then polarization increases. Means if the electrical field is not very high, then polarization is proportional to E. So polarization is equal to the constant, proportionally constant chi E into E. Chi is the electrically susceptibility of the material. So P will be equal to the susceptibility chi E multiplied by. So here we can take that ED will be equal to chi bata epsilon 0, which is equal to ED is equal to sigma bata epsilon 0 and epsilon R. Means ED is the total, this will be equal to total charge and the sigma divided by the epsilon for the medium. So we can write sigma bata epsilon 0 into epsilon. So ED is equal to this much. So we here substitute the value of P. P is equal to rho and rho is equal to sigma 1 minus 1 bata epsilon r. So rho 1 minus 1 bata epsilon r. This will be equal to chi multiplied by E, and E is equal to sigma bata epsilon 0 epsilon r. So here we cancel sigma here and cross multiply it. So chi will be equal to sigma r multiplied by 1 minus 1 bata sigma. So that will be equal to sigma r minus 1. So chi will be equal to epsilon 0 into sigma into epsilon r minus 1. So this relation is very important. So the susceptibility of the material will be equal to epsilon 0 bracket 1 minus epsilon r minus 1. So this relation is very important in the examination point of view. So here we can conclude here that what is the effect of electrical field. The effect of electrical field due to the electrical will be reduction of electrical field. Electrical, when there is no dielectric, electrical field was E0. When we put the dielectric, then due to the polarization, the electrical field is in opposite direction. So total electrical field will be equal to E0 minus EP. Now this will be the, so there is a reduction of electrical field. So by the insertion of the dielectrical, the electrical field is reduced. Now we know the value of sigma. and we can write the value of E0 and EP. E0 is sigma bata epsilon 0. This will be sigma P bata epsilon 0. Substitute this value. So we can the ED will be equal to this minus this will be equal to sigma minus sigma 0 bata epsilon 0. Now this will be equal to the sigma divided by sigma 0 epsilon 0, and here we put it and we cross multiply, then we will get sigma P is equal to sigma bracket 1 bata epsilon 0. This relation is good. Now we will take the what is the polarization density. Polarization density is dipole moment which is due to the induced polarization divided by the volume. So induced charge here will be plus q is there, minus q with this side. This charge will be induced due to the external electric field. So what will be dipole moment? Dipole moment will be equal to q multiplied by the distance. This will be dipole moment. What will be the volume? Volume will be this distance is the and area of cross section is A. So A into D, we divide it here. So P will be equal to QP bata A, and QP bata A is charge density due to polarization. So sigma P is equal to P. Here we put the value of sigma P from this relation. So P will be equal to sigma into 1 minus epsilon 0. Now, if we apply the electrical field, now if we increase the electrical field, as the electrical field is increasing, then the alignment of the molecules will be more. Means the dipole moment will be increased. So dipole moment will be proportional to the electrical field. Then proportionality constant is chi E, which is known as the electrical susceptibility. So ED will be equal to sigma bata epsilon, that is equal to sigma bata epsilon 0. Now we substitute the value of P from here and ED from here, and we solve it, then we can find chi is equal to epsilon 0 epsilon r minus 1. This result is very important from the exemption point view is also.